Welcome to the fastest way to learn data structures and algorithms with this premium revision material. Today we are mastering LeetCode 300, the longest increasing subsequence challenge. This is a classic dynamic programming problem that shows up constantly in technical interviews. Let us look at the problem statement. We are given an integer array nums. Our goal is to return the length of the longest strictly increasing subsequence. A subsequence means we can skip elements, but we must keep the original order. Every chosen value must be strictly larger than the one before it. Think of it like a film festival curator building a lineup. You walk past a row of movie posters, each with a star rating. You may skip any movie, but every movie you select must have a higher rating than the last one you picked. Your job is to build the longest possible chain of rising ratings. Let us dive into the algorithmic strategy. We use one-dimensional dynamic programming. We create a DP array where DP at index I stores the length of the longest increasing subsequence that ends exactly at index I. Every index starts at 1, because a single element is always a valid subsequence of length 1. For each position I, we scan every earlier position j. If nums at j is strictly less than nums at I, we can extend the chain that ends at j. We update DP at I with the maximum of its current value and DP at j plus 1. The final answer is the maximum value in the entire DP array. Let us dive into the dry run. Look at the screen. Our input array is 0, 1, 0, 3, 2, 3. On top we see nums, and below we track the DP array. Pointer I marks the current ending position, and pointer j scans all earlier positions. We initialize every DP cell to 1, because each element alone is a subsequence of length 1. First, I is at index 0 with value 0. There is no earlier index to compare, so DP at 0 stays 1. Next, I moves to index 1 with value 1. J scans index 0. 0 is less than 1, so we can extend. DP at 0 plus 1 equals 2. DP at 1 becomes 2. Now I is at index 2 with value 0. J at 0 gives 0 less than 0, which is false. J at 1 gives 1 greater than 0, so we skip. DP at 2 stays 1. I moves to index 3 with value 3. J at 0 gives 0 less than 3, so DP at 0 plus 1 is 2. J at 1 gives 1 less than 3, so DP at 1 plus 1 is 3. J at 2 gives 0 less than 3, so DP at 2 plus 1 is 2. The best is 3, so DP at 3 becomes 3. I is at index 4 with value 2. J at 0 gives 2. J at 1 gives 3. J at 2 is skipped because 0 is not less than 2. J at 3 is skipped because 3 is not less than 2. DP at 4 becomes 3. Finally, I is at index 5 with value 3. J at 0 gives 2. J at 1 gives 3. J at 2 gives 2. J at 3 is skipped. J at 4 gives 2 less than 3, so DP at 4 plus 1 is 4. DP at 5 becomes 4. The dry run is complete. The maximum value in DP is 4, so our final answer is 4. Now, let us look at the Python code. We handle the empty array edge case first. We initialize DP as a list of ones with the same length as nums. The outer loop walks I from 1 to the end. The inner loop walks j from 0 to I minus 1. When nums at j is less than nums at I, we update DP at I with the max of its current value and DP at j plus 1. Finally, we return the maximum value in DP. Looking at the complexity, the time complexity is O of n squared, because for each I we may scan all earlier j values. The space complexity is O of n for the DP array. And that is the longest increasing subsequence challenge, mastered. Save this video for your next technical interview, and follow Leo Academy for more such premium DSA guides.